This is chapter P2 on real numbers and day 1. So first what I have here is this diagram with all the real numbers, and it's kind of an organizational chart. So we've got all these different types of real numbers, and we've got, let's see, we'll start in the middle and on the inside here. These are natural numbers. Starting at 1, counting to infinity, those are natural numbers. To talk about whole numbers, you are including the natural numbers. So that's why that natural numbers circle is within the whole numbers, because natural numbers are part of the whole number set of numbers. So whole numbers start with 0 and go on to infinity. And just like the list shows here, there's no decimals. And when we look at integers, integers not only count the whole numbers, but we also count the positive numbers and the negative numbers. So going from negative infinity to positive infinity without decimals again, those are integers. And then rational numbers, which kind of contains all of these numbers, are numbers that can be written as a fraction of two integers. Fraction of two integers. So it can be positive, it can be negative, it can stay as a fraction, or for example, 4 over 2 is the value of 2. That's still a rational number. So all of these numbers are considered rational numbers. Typically, we see them as fractions. And then there's another type of number in the real number set called an irrational number. An irrational number are numbers whose decimal is non-repeating and never ending. So if you took the square root of 2 in the calculator and you look at all the numbers listed there, and they stop it only because the calculator cannot display numbers going on forever. But you'll see that none of the numbers repeat. Though they might repeat, but they don't like go into a pattern of repeating. Same thing with the square root of 3, pi, negative, square root of 5, anything that's a square root number that actually cannot be simplified, like the square root of 25 is 5. So that would end up being a rational number, not an irrational number. So the square root of 24, however, cannot be simplified like the square root of 25. So therefore, that would be an irrational number. So I just have the kind of a basic definition over here on the right-hand side to try to explain this organizational chart and what these numbers mean. But hopefully, just by going through this with you, that makes some sense. Looking at some real number properties, we've got commutative, associative, identity properties, and inverse properties, and distributive. In this chapter, we are mainly concerned with commutative, associative, and distributive. Identity and inverses are important. We just don't talk about them a whole lot in this section. A commutative property is when you can change the order of the numbers that are being added or being multiplied. So if I have a plus b, I can switch those around and have b plus a, and that means the same thing. If I had three numbers like a plus b plus c, I could rewrite that. I could put b plus a plus c. I don't need to change all the numbers or values, but even just a couple. And that's commutative property of addition. And multiplication, also the commutative property applies to multiplication, similarly with 3 digits or 3 values. The associative property, though, is not moving the values around, but moving the grouping of the values around. So here you have a plus b plus c, where b plus c are in the parentheses, and you can switch those parentheses to be around a and b first, so that you have to do that adding before you add the c. Well, with all addition, it doesn't affect our answer, and therefore these are equal. Same thing with multiplication. And then distributive property is when you have something being multiplied by a grouping. So if I take A times B plus C, I would take A and I would distribute the multiplication times the B and also times the C. But the addition keeps them separate. So A times B plus A times C. If I had, and it doesn't show up very well on here, but let me grab a pen in black. If I have a C out in front here with this second little example, I have C times the quantity of A plus B. So that C is going to get distributed and give you A times C from the first one plus C times the B, so B times C for the second one. Um, the inverse property is, in addition, what gets you to 0. So if you have A and you're going to add, you have to have the opposite of A. Like kind of like 5 plus -5 would be 0. When you're talking about inverse for multiplication, you multiply the two values to end up with an answer of 1. So A times 1 over A, that would give you A over A. And anytime you have a number over itself like that, the value is 1. And then identity, if you take A plus 0, it equals A. That's weird, it said 0 there. If I take 0 plus A, again, it's going to be A. When I take A times 1, that's going to equal A, which is correct. And then 1 times A is equal to A. So identity, even though you add or multiply times something, its value did not change. It kept its identity. Okay, so now let's look at a couple examples here. Let's rewrite the expression using the given property of real numbers. Using the associative property of multiplication, we want to rewrite 7 times 3 times x. So remember, associative property changes the grouping symbols. So we're going to take the parentheses and keep them, take them away from the 3 times x, and we can move it over and write 7 times 3 inside the parentheses and leave the x on the outside. You also could have applied even the commutative property within and had 7 times x in parentheses times 3, but that would be a combination between commutative property and associative property. Here, they only asked you to do associative. So let's look at the next example here. Use properties of real numbers to write the expression without parentheses. So this, when we look at this, we need to realize that this is talking about the distributive property. And so when we do distributive property, we take the number that's on the outside. We're used to seeing that number out in front, but it can also be in the back of the parentheses as well. We would take 8 times A and get 8A, and then we would take 8 times B and get 8B, and because we're subtracting here, that stays as subtraction there. So we get 8A minus 8B. All right, let's look at some properties of fractions. With addition, you would need to have a common denominator. So if we have A over B plus C over D, we would have to use both of these denominators to get a common denominator of B times D. And if I know that I'm going to multiply the denominator times D over here, I also need to multiply the top times D. And that's how you get A times D right there. And then for the second fraction here, I need to multiply D times the B. So I put B down there with the D, but I also have to affect the numerator and get B times C. So when we combine these together on the top, I can see I have A times D plus B times C, which is what I have right over here. And my denominator is now B times D. So here's an example with numbers. I'm going to take 3 and 5. So I'm going to multiply the first fraction, both top and bottom, by 5, and I get 2 times 5 over the 3 times 5. And for the second fraction, I'm going to multiply by 3. So 4 times 3, or 3 times 4. And the denominator, again, is going to be the 3 times 5. And then you go ahead and simplify that out. You get 10 plus 12 to get 27 over 15. And anytime you can reduce a fraction, you want to reduce it for your final answer here for 9 over 5. When you already have a common denominator, you do not need to change the denominator. You could just go ahead and add, and you have the two numerators are added also, so you get a plus d, a plus c over d. Same thing here, the denominator will just stay the same, and you add the two numerators, 2 plus 3, to get 5, and 5 over 5 can be simplified to 1. When we have two fractions involving multiplication, you just multiply straight across both the top and the bottom. You would get A times C over B times D. And then fractions with division. We use the reciprocal rule where you take the dividend, or the divisor, sorry, the second fraction. So A over B divided by C over D, and you're going to take the reciprocal of it. The reciprocal means you're going to take the bottom and move it to the top, and the top moves to the bottom. So you have D over C. And now we can multiply. So we're doing the reciprocal, so we can change this to multiplication and go straight across with those values. We get A times D over B times C. With the numbers, you can see 4 over 5. The reciprocal is 5 over 4. And then you multiply. Once you take the reciprocal, you're going to multiply them and go straight across and simplify. Let's look at an example. Perform the indicated operation. We want to subtract 2/3 minus 3/5. Subtraction is very similar to addition. So if you need to subtract two fractions, you still need a common denominator. So my common denominator, I could take 3 and 5 and use both. So I'm going to take this fraction and multiply times 5. And the second fraction, I will multiply by 3. 2 times 5 is 10 over the 3 times 5, which is 15. 3 times 3 is 9 over the 5 times 3, which is still 15. And we are subtracting. So 10 fifteenths minus 9 fifteenths. Now when you subtract, you just go straight across. 10 minus 9 is 1. Our numerator will be 1. Our denominator will be the 15. Looking at the second example, we have 1 plus 5/8 minus 1 over 6, 1/6. I could change the 1 into a fraction, but I could look at my denominators here. If I did 8 times 6, that would be 48, which would work, and that would be fine. We would just have to simplify later. But if I can look for a number that these both go into that is smaller than 48, then I might not have to simplify later. So if I think about it, 8 goes into 24, and so does 6. I can change all my denominators to be 24. So for 1, I'm going to have 24 over 24. For the first fraction, to get 24, I would need to multiply 8 times 3. So I'm going to multiply the top and bottom times 3. That gives me 15 over 24. And 6 times 4 is 24. So I'm going to multiply those numbers, top and bottom, by 4, which gives me 4 over 24. and then I subtract 15 minus 4. Oops. Now I'm first going to add 24 plus 15, which is 39. And then 39 minus 4 is 35 24ths. It's an improper fraction, so I'm going to rewrite that. So 35 over 24. If I subtract 24 from 35, I get 11. So I get 1 and 11 24ths. Next page here, properties of absolute value. The absolute value of A is equal to either A itself if it is a positive number. So reading this A is greater than or equal to 0 is really just saying if A is positive, then your answer is just going to be the same as the number was inside the absolute value. But it's going to be the opposite value if A is a negative number. So if I have negative 3, the opposite of A would be positive 3. So my outcome should always be positive. So when I look at this area right here, okay, this is what they're saying, is that the outcome is the same if A is positive, but is opposite when A is negative. So absolute value of 5 is 5, but the absolute value of negative 3 is the opposite of negative 3, which is positive 3. All right, let's look at this example. 2 minus the absolute value of negative 12. So I always want to work from the inside out. And the absolute value of negative 12 is positive 12, but I'm still subtracting. So 2 minus positive 12 is negative 10, but absolute value of negative 10 is positive 10. And that's my answer. For the second one, negative 1 minus the absolute value of 1 minus the absolute value of negative 1. So we're going to start on the inside, which we're going to take care of that negative 1. The absolute value of negative 1 is positive 1, so that's right there. So here we had 1 minus 1. Well, 1 minus 1 is 0, so you get the absolute value of 0, which is still 0. And you have the negative 1 minus that on the front, on the outside. So negative 1 minus the 0 gives you negative 1. And that is the end of day 1. So you should be able to do the assignment. And I hope everything makes sense. Good luck.